Oh, time for algebra. All right. Going to keep working on our essential question and focusing on the exponents part still today. So yes, last week, the beginning of this chapter was 7.1, we worked on multiplying exponents, right? The multiplication properties of exponents. This week, starting off this week, we're going to talk about the division properties of exponents. So we're going to start off with our first rule for how to deal with these exponents. Remember, we're trying to make them simpler, and simple means, well, here's an example we have. This one looks kind of simple. Like the top looks like one of the answers we had last week. But when we have a whole fraction like this or exponents dividing, right, that's our division rules, that's not simple yet. We have to get rid of that if we can, as much as we can. So really the main thing is we don't want the same base, so an x and an x on both sides of the fraction. We want to get rid of one of them if we can, and we usually can. So we're going to start today with our rule about the quotient of a power. The quotient, that's basically a new vocab word. It's come up before, but might be a little tricky. A quotient just means divide. It's the fancier word for division, right? When you're dividing things, you're making a quotient. So let's look at our example over here. If we're trying to divide 4x to the fourth by 2x squared, what are we going to do? Well, break out my colors. And I'm going to start with the coefficients just like last week. Coefficient of 4, coefficient of 2. So I know how to do 4 divided by 2. I've done that before. And it equals 2. All right, nice. That's figured out. Now let's look at the bases. Do we have two matching bases? Yes, or it wouldn't be a problem. We've got an x base and an x base. And we're going to check what our rule is. If we have quotient of power, we're dividing these exponents. We're going to subtract the exponents this time. Last week when we multiplied, we added the exponents. Now when we divide the bases, we're going to subtract the exponents. Okay, so let's check. We've got x to the 4 minus 2, which is x squared. Okay? Let's put it back together. We have our coefficient answer, our base x answer. So together we have 2x squared. Final answer. Wow, that was a bad circle. Anyway, so that's how that one worked. Let's look at it from a different angle. Okay? So like on the warm-up from last week, we should expand our exponents, right? 4x to the fourth is the same as 4 times x times x times x times x. And 2x squared is the same as 2 times x times x. Okay? So if we blow it open like this and we expand them, we see that we can divide the coefficients. We can do that. 4 divided by 2, still 2. Then we can check to see if we have matching pairs in the numerator and the denominator of the same base. We have x and x. They will divide out. We have x and x. They will divide out. What do we have left? X times x, which is x squared. So put it back together. This 2, 4 divided by 2 is 2, not 1 over 2. So we know the 2 is going to be in the numerator. So it's not going to be below the other numbers. So we have 2, and we got our variable answer, 2x squared. Good thing we got the same answer. Okay. So that's our first rule. I'm going to do one of the practice problems from the packet. So, after the warm-up page in your packet, we're going to be looking at the first page of practice problems. And we're going to start with number 3. So if you want to follow along, go grab that paper. We have -2 times y to the 7th divided by 14 y to the 5th. Okay? This time, let's start with our coefficients again. -2 divided by 14. Now, I can put that in the calculator. I can get some decimal. Yuck. What we can do is check, what do both numbers divide by? We can factor that out. Well, 2 divides by 2. There's 1 2 here. And 14 divides by 2. There are 7 2's there. So my result will be -1 divided by 7. -1 over 7. Okay, that's good reducing. Now, if we can't divide this anymore without getting a decimal, and that's okay. I guess if you want a decimal there, I'm not worried about it, but this is going to be easier to look at. Okay, then we use blue for our variables. They have the same base, y and y, so when we're dividing them, we will subtract the exponents. So we've got y to the 7 minus 5. Oops. Okay. So that will be y squared. Y to the 2nd. 7 minus 5 is 2. All right. Put it back together. So I'm going to write my fraction first. This might be a little tricky. -1 divided by 7. Then I need to put my y squared somewhere. I got to pick if it's going to be on the numerator or the denominator. If there's no numerator or denominator in this part, it's the numerator. So, whoa, lost my hand. It is y squared. Now that's a good answer. We could make that 1 invisible if we wanted. So it would just be -y squared over 7. Okay. Let's move on down the line. Okay, so our second rule about dividing exponents is a little bit like what we did last week. We had the power of a power last week. Now we have the power of a quotient. So we have this quotient, right, division. We are dividing a to the 4th by a to the 3rd. And that whole thing has a power. So that's why it's a power of a quotient. And it's mostly the same rule as last week. So when we have the power of a quotient, if there's a power outside of parentheses, you distribute the exponent. You give everything inside a copy of the exponent. Okay? And we remember, when you get an exponent and another exponent on top of it, they multiply. So this top side is going to be a to the 4 times 5. And the bottom side is a to the 3rd times 5. Okay? We'll get a to the 20th, a 20 divided by a 15. Not my best 15. Okay? And then 20 we're dividing now. Now it's just a nice division, which means, remember the other board over there? Which means we subtract 20 minus 15. So the end will have a to the 5th, right? 20 minus 15. I'm standing on a plant. That's why. Okay. So I'm going to come back over here. This is our final answer. That one was not too tricky. So let's do a little bit of a trickier one from the packet. Okay? This is still on the first page of practice problems. So the first page after the warm-up. And this is going to be number 5. Ooh, this is an exciting one. Number 5. Okay. We have 2 r to the 5th, w to the 3rd, divided by r to the 4th, r to the 4th, same thing, w to the 3rd. Okay. Now there's 2 ways you could, and all of that is to the 4th. Okay. So there's 2 ways you could do this. You could try to solve inside first and then do the exponent on the power, or you could just distribute the power, then solve everything else. So it's a balance. You can pick which way you want to do it. I'm going to try to solve inside first. When I get stopped there, then I will distribute the 4. So let's start out. We have no dividing with the coefficient, right? We just have a 2, so it's just going to be a 2 on the top of a fraction if we still have a fraction. Then I've got, this base and this base. Both of them are r. So if it's the same base and they're dividing, we subtract the exponents. So 5 minus 4, we're going to have r to the 1 left. Now, you don't have to write that 1, but I'm going to keep it for later just to remember. Okay. Then I'm going to check on my w's. We got w to the 3rd, w to the 3rd. So same base. That means when they divide, we can actually subtract them. We will subtract the exponents. So 3 minus 3 is 0. So it's gone. That's something we're going to learn the real technical reason later. But 3 minus 3 is 0, so the w's are gone. Okay? They divided out. So this is what we had inside, finished. Let's put our parentheses back on. And then we have to bring our 4 down. Our power 4. Okay. So power 4 needs to distribute. We'll give a copy to each piece, right? This thing needs to get to the 4th power. Yeah. That coefficient needs it. And the r to the 1st power needs a copy. So it's times 4. Because we know from last week, power of a power is multiply. So if you have an exponent and another exponent right on top of it, they multiply, not add. Okay. So what is 2 to the 4th power? Well, that's 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 16 as our coefficient. And then we have r to the 1 times 4. 1 times 4 is 4. So it is r to the 4th. Finished. Okay. So you would get the same answer if you chose the other way to do it. If you said, oh, I want to distribute the 4 to every piece first, I'll do the multiplication and the exponents that way. Then I will subtract the dividing exponents. I will get the same answer. It's just, one person turned left and then right. One person turned right and then left. Same thing. So I think this was easier, but it might change in different problems. Okay, last board. So on this board, we've got one freebie, one really easy rule, and one really hard rule. So we're going to do a speed round for the easy one. Okay, here's the new rule. Easy rule. If you have a zero exponent, whoa, that's a good line. If you have a zero exponent, the result is always 1. Okay? Ready? Let that sink in. All right, speed round. 2 with a 0 exponent. 1. X with a 0 exponent. 1. 5x cubed with a 0 exponent. You guessed it, 1. Smiley face plus $$ to the 0 power. 1. Okay, so that's the simple rule if you have a 0 exponent. Okay, the other rule on this board is if you have a negative exponent. So now we had 0 and we've had positive exponents, right? Just x squared. But if you have a negative exponent, the rule is you move the whole thing, if it's x to the -2, you move it to the other side of a fraction, and the exponent is now positive. All right, you might want to write that down or think about it for a second, but it is a little hard to figure out right away. So let's try an example of that. Okay, this is a very quick example with no other simplifying. What if we had 5x squared dividing by y to the -3rd? Okay. We can't divide them really because this one's an x base and this one's a y base. So the other thing we need to simplify, this cannot be simplified already. This is not the simplified version, I mean. Because we can't leave it with a negative exponent. So we want to get rid of the negative exponent. And the way to do that is with our new rule. So let's just follow it step by step. The new rule says move to the other side of the fraction. So I take this whole, let me get a different color, the purple. I take my base and my exponent that's negative, just the part attached to the negative, and I'm going to move it to the other side of the fraction. It's coming up here. Okay, so let's write a new one. This equals, the 5 stays up there, the x squared stays up there, the y to the -3 moved up, and it's now positive exponent. So it's y to the +3. And that is simplified. Now we're good. No negative exponents, A+. So for a simpler example, or here's the rule. If we have, x to the -1, that should be changed to 1 over x to the 1. So I moved it under a fraction, right, to the other side. I moved it under the fraction, and I made it positive exponent. Or the other way around. What if I have 1 over x to the -1? Uh-oh. Well, I do the same thing. Started on the bottom, but I move it up top and make it positive. So it's going to be x to the 1. Now you might say, oh, you moved it to the top, so you need to have it be a fraction. This is okay too, but you don't need to write divided by 1. That's just always there if you don't write it. Okay? Let's try an example of this version. Practice problem number 1 from the page 2 of your practice problems. So this is page 2 of practice problems, and it's number 1. Okay. We have m divided by m to the negative 4. Uh-oh, it's not simple. First of all, we have 2 of the same letter, and they're on different sides of a fraction. That doesn't work for simplified. The other hand, we have a negative exponent. That's also bad for simplifying. So I'm going to use what we just learned. I have a negative exponent. I'm going to move it to the other side. So this whole guy is coming up here. So we've got m times m to the negative 4. When you move it up there, everything that's above it, it will be multiplying together. That's why I put times there. When we move it up there, they will be multiplying together. Oh, I made a mistake. Good catch. When I move it upstairs, it's not negative anymore, right? That's the other part of our new rule. The exponent is positive now when we move it. Doesn't matter if we move it upstairs or downstairs, but when we move this negative exponent, it becomes positive. That makes it simpler. Okay? Then we just have one last thing. Oh, this is from last week. So let's remember, if we multiply bases, we add the exponents. And this has an invisible 1. That's a bad one. That has an invisible 1 as its exponent. So it's not a 0 up there, because a 0 is very different. A 0 exponent. But it is a 1. Okay? So 1 plus 4, we get m to the 5th power. Final answer. Okay, so there are some pretty tricky problems in this set of practice problems, right? Number 5, not number 6. Number 6 might look scary, but there's a nice trick. Just remember, whoops, that's my countertop. Just remember, a 0 exponent, whatever's inside that 0 exponent, so if there's parentheses, blah, blah, blah in here, and a 0 exponent, it just turns into 1. So that can help you with some of the practice problems that look scary. But number 5 is tricky. So just try step by step. Think about the rules that we've talked about. They're in your packet too, last week and this week. And you can go step by step to try to solve them. Remember, we've got question and answer at 11:15, Thursday and Tuesdays. You can come in and ask us questions at 1 o'clock every day. Not Friday. Monday, Tuesday, Wednesday, Thursday. On Friday, you can come in at 9 a.m. to noon. That's 3 hours you could check. And on Tuesday, Thursday at 7 p.m., in case you're busy all day, will be available if you want to talk about answers or how to solve these. So try your best. Use your steps. All right. See you later.